The next thing we're going to look at is a hash table. So a hash table is basically an array which has indices that are not directly matched to a particular number necessarily. So the general idea is that arrays are really fast to be able to access the information. However, how do you fit something like just a series of letters into a hash table and make it an index from like 0 to 99? So we use something called a hash function to do this. So we take these things, we somehow mash it up, and we get a number out on the other side. And then we put that in the table. So for example, if some hash function happens and we get a number 66 out, we put this in the slot. And this is nice because this is really fast. So we have the accessibility of an array, the speed of an array, but we can use any kind of data to get it in. We'll go into what a hash function is later on. So likewise, you would have something like ABC goes into 98. Now what happens if you have two things that collide? So let's say this DCBA also ends up in number 66 here. Well, there's a couple ways you can deal with this. The first is you just look for the next empty slot in the table, and you put it in there. So in this example, it would go down in this slot. And then if we're looking for this later on, we start in 66 and just keep walking down the table until we find the thing we're looking for. So this doesn't necessarily have to be a string. This could be a data structure of some sort. So maybe this is an employee record, and we would use this to match it up. Another way of dealing with this is called chaining. So chaining, you actually create a linked list of these things at slot 66. And that's what we're going to use in our project. So what about this hash function? What is this? So what you're trying to do is you're trying to take this stuff and turn it into a number that fits in your hash table. So one way might be you just add up the letters in ASCII, you get a number, and then you do the modulus, the percent sign in Java and C++, and by 100 and get out the number 66. And then that's what goes in this slot. So this 100 here is basically the size of the table. So when you do the division and you get the remainder back, that's what you have. Now this is not great in some ways because the DCBA is also going to end up in 66. This ABCD22 is also going to end up in 66. So what happens when you start getting a series of collisions? What you'd like to do is respread the table out again so that you have the quick access without having to jump down basically a linked list where you've lost all the power of the array. So what you can do is you can actually resize the table. So if we make the size of the table 200 now, basically rehash everything in, then we get some changes to where they're placed. So ABC is in 198. This one here actually goes to slot 166. This adds up to 366. Now we still have the problem that this thing, DCBA and ABCD, both end up in the same slots again. So your hash function should probably have something that is unique about that particular string. So maybe we add on a unique ID number to ABCD, DCBA, so that eventually this data spreads out and we don't run into the collisions.